Okay, for problems like this, I like to start by sketching out the path so that I have an idea of what the solution is going to look like. So let me draw a coordinate axis here. And so our first vector is going to be 2.4 miles in a direction 23 degrees south of west. Okay, so I will call that vector A. That makes an angle of 23 degrees south of west. Vector B is due west 1.9 miles, like this. And then vector C is 3.4 miles, 28 degrees east of north. So if that direction is north, we need to go east of north a little bit. And this is going to be the longest vector because it's the longest length. And that angle is 28 degrees. Alright, and therefore my resultant, I think, is going to look like that. My resultant R, it's going to have a little bit of a negative x component and a positive y component, and the two components should be comparable. So let's work through this problem then. We'll start with vector A, which looks like this. Makes an angle of 23 degrees south of west and has a magnitude of 2.4. So the x component of A is negative 2.4 cosine 23. Right? You got to put that negative sign in there because the generally speaking, we make to the left or west negative, and we make down negative as well. Okay? So that's minus 2.209. The y component, also negative, is minus 2.4 sine 23, right? And that's minus 0.938. Just to be clear, with this triangle that I've drawn, so I've drawn a triangle like this. This is 2.4. So this is the x component and the y component, right? And so I'm using the trig identity that cosine 23 is equal to the adjacent side over the hypotenuse. Right? The magnitude of the adjacent side is the x component, and the magnitude of the hypotenuse is the vector itself A. And that works out to be, if I cross multiply, AX is equal to A cosine 23. And in this case, I've added on a negative sign to indicate the direction. Alright, let's move on to vector B. That's pretty easy. B just points due west, 1.9 miles, so Bx is minus 1.9, and By is 0. And then vector C looks like it points 28 degrees east of north, like this. I prefer to measure my angles with respect to the x-axis, so that would be 62 degrees north of east. That way my x component always depends on cosine, and my y component always depends on sine. So this will be Cx and Cy. Cx is positive 3.4 cosine 62 because it points to the right. That's 1.596. And Cy is positive 3.4 sine 62, 3.002. To find the resultant, Rx, I'm going to add up my three x components. So that's minus 2.209, minus 1.9, plus 1.596, which is minus 2.513, and then my y component is minus 0.938, plus 0, plus 3.002, which works out to be 2.064. So that's kind of what I expected at the beginning. If you look up here, I expected my x component to be negative and my y component to be positive and to be comparable to one another, and they are. So now I need to reconstruct the resultant to finish the problem. So I've got Rx, which is 2.513 The negative sign is used in the fact that this points to the left. And then the y component is 2.064. That's positive, so it points up. And I need to find the resultant, and I need to find the angle theta. So the magnitude of the resultant can be found in Pythagorean theorem. And that's 3.3 miles. And then theta can be found because the tangent of theta is equal to the opposite over the adjacent. So tangent theta, opposite divided by adjacent. That means that theta is equal to the inverse tangent of opposite over adjacent. The opposite side of the angle theta is the y component 2064, and the adjacent side is the x component 2.513. So that angle is 39 degrees. And in this case, it's 39 degrees. There's west and here's north, so it's 39 degrees north of west. You got to include that information as well. So there's my answer. Now I want to point out that I didn't make the 2.53 negative. I made it positive because at this point I'm just solving for a triangle. If you make that x component negative in the tangent, then what will happen is your calculator will split out a negative value for theta. It'll tell you that theta is negative 39 degrees, which actually negative 39 degrees is this direction, right? And that's no good. That's not right. Your calculator doesn't know. If you make the inverse tangent argument negative, your calculator doesn't know whether it belongs in the fourth quadrant or the second quadrant. But I know from my diagram it belongs in the second quadrant. So I'm just going to leave all these things positive because I've drawn my diagram correctly. And then the 39 degrees north of west has all the information in there. That's it.